Okay. Uh, so good afternoon, everyone. Myself, Sai. So I have industry experience of 10 years. So I serve for various companies, KPIT, on BMW, some other companies also. Hitachi also I have served, and I some serve for some of the clients also. So welcome to this presentation on embedded system. Today we are going to explore the hidden wall of specialized computing. And while most of the people interacting directly with general purpose computers like laptops and smartphones, but there is another entire world of dedicated computer quickly running our world behind the screen, right? So you are completely beginner. So let me know. So everyone is experienced or else everyone aware of embedded everything. Hello. Take, Hussein. So let it be interactive. Why? Because we are not much numbers, only 4 5 only. So if you get interacted, I will give you more data so that it will be useful for you guys. Hello. Okay. Fine. Okay. Coming to the slide here. So to understand what is embedded system is like, let's look at the definition, right? It is a small dedicated computer built inside a large device to perform one specific job automatically. So label it. So to understand, like you have like laptop or PC, which are general purpose computers meant to browse the web, right? So playing games and writing documents all at once. And embedded system have its one single chip dedicated task, right? So for that we will go for embedded. What and if you want to any example, for example, we have inside the washing machines. Washing machines also need to be controlled. So that inside the controller we need to write some code. So that will be done by the embedded engineer and the ATM machines. The ATM machines are also having the microcontrollers and traffic lights and whatnot. Every over 98% all controller are done by the embedded only, right? So there we will be more into the embedded systems then evolution. So here mostly so many evolution has came. So one year they compute like embedded things will come, and after that there will be internets of things, and 2000 plus 10 onwards there will be my OTs comes into picture, then laptops, TVs, everything whatnot, everything will be in embedded only. So that is the main agenda. So please guys, if you have any doubts at any point, please be interactive so that I can. Okay, now now is fine or else I need to still increase.
Fine, Uday. Fine.
Yeah, fine side.
Yeah, okay. So you can stop any point of time so that it will be a little bit interactive. Okay. So after this, there will be a dedicated functionalities like what makes an embedded system unique, and they share several core characteristics. First, they have a dedicated functions like they do one thing their entire life, and second thing like a feature like a real-time response, meaning they must react to the input within a fixed and predictable time frame. Okay, so that comes into the real time response. When it comes to the small size means we will design any type of product that will fix into small size. Because suppose if you take any head earpods anything, right, that is also embedded system, that also need to be take care, that will comes into small size. Then power usage, so how much power we utilizing. If you take the any headphones, if you take any small mobile phone, everything will be very small, like zero point 0.5 zero point 0.6 amperes it will be consumed. That is the main comes into picture, power consumes, right? Then after that, highly reliable, so it should work 24 by 7 every week, right? It should not stop anywhere. So then we will comes into picture like it should be battery, it should be some other power source, anything will comes into picture. Then it should be a low cost, the embedded product should be a low cost. Then only any product any person will choose, otherwise it will be useless. If the cost is more, the people won't take it, right? So main agenda is the cost also we need to take consider. Okay, that is the main thing. So coming to the basic components, right? So here the basic component, right? Let's look at under the view, like every embedded system relies on the five basic building blocks. Like at the center is the processor, which acts like a brain and running instructions and controlling all the other components, right? So next to the memory, so RAM stores the permanent program firmware, which RAM and memory, flash and whatnot, everything, any device is, if you want to store any data, memory has to be there. That is the one major component of any embedded system. Then input sensors, like if you want to interact with, suppose if you take a mobile system, right, your keypad, your screen is the input and the touch screen is the input. So real world, that is the real world input. The outputs, like if you want any LEDs, anything should be glowing, any motor should be run, or else if you take and consider any washing machine, after some time it should give the buzzer, okay, it is completed, like that. So something like the some outputs, or else even mobile phone, after pressing the some mobile number, it should ring the other person. So it will be like that. That is the output devices. Then power supply, so which is the very essential for any product. If we have input, we have output, we have memory, we have processor, but if you don't have power, it's a waste, right? So the power source is the solar panel or battery. That is the main things. So coming to this slide, so here I will explain what is the types of embedded systems, like what we have. So embedded system can be categorized into four primary types based on their functionality and connectivity. First, standalone system. What is standalone system? Means which operate entirely on their own without an internet or the device connections, like digital cameras or calculators. That is the standalone systems. Next one is real-time systems. Okay, where time is everything, like, and they must respond to events within the strict deadline. Think like if you have aircraft autopilot or the medical veterinary, these are the major things. So it comes into picture real-time systems. When it comes to the network systems, what is meant by network system? Like network system, nothing but the talk to the other devices or the network, like smart thermistors or home routers. Latest we have, right, have mobile, that we have. Okay, last one like mobile systems, so which are portable and whatever the power device focus, right, that will comes into picture. So I think you people are aware of what is difference between microcontroller and microprocessor. So I will give you the glance, like frequent points of difference between MCU and MPU, right? So there will be MCU we have everything on one chip only, memory, input and output and the processor unit, everything. That will be the microcontroller. When it's come to microprocessor, right, only CPU we have. Remaining thing, memory and other chips inputs, outputs should be taken from the output other side. That is the major difference, right? When it comes to the difference, right, that we have the ARM controller and Arduino and STM32 we have. And when it's come to processor, we have Raspberry Pi and Intel Core. These are the major differences. Okay. So till this point, anyone have any doubt?
No, sir.
Yeah, I was just giving overview. I think I feel everyone is an experienced person. So I feel if anyone is from not from embedded background, so that I have giving the glance. Okay.
Yeah, that's better.
So after starting that one, if they don't aware of any basics, right? Again, it will be trouble for everyone. So coming to the memories. So how many types of memories we have? First one is ROM. So memory management is incredibly precious in embedded architecture, and the different types of memory serves a distinct roles. When it comes to RAM, right, it only read only memory, so it holds the main program code permanently. Okay, so that retains the data when the device is powered up. That is the main purpose of the RAM. Okay, so when it comes to the RAM, so the abbreviation of RAM is random access memory. So ultra fast temporary workspace, right? So used the program running on the RAM. That is the RAM. So when it comes to flash is nothing but, so when it's power off, power shutdown, anything is happened, so that time the data should not be missed. So that time we will store the data, whatever the data that will be stored on the flash. So that purpose mainly we will use the flash. So finally other memory is the EEPROM, electrically erasable programmable prompts. So it will store the same type of data with the different type of memory. So it is same data, small memory, and it calibration data. Any important data if you want to store, we can go for the EEPROMs. That is the one type of data. That's the main majorly we will use the memories in embedded systems. Then coming to the inputs and outputs. So we have various inputs. Like,
Yeah, Sai, it's Sumit raised hand.
yeah, yeah,
Yes, can you please let us know, like, you mentioned like in different domain, different domain embedded systems are used, correct?
yeah, yeah.
So what is the role of AUTOSAR in that specific?
So AUTOSAR is one of the domain. So I was trying to give you the basic, like it's like a base of the AUTOSAR. So in top of the embedded, you can build anything. You can build aerospace. You can go for the defense. You can do the AUTOSAR also. So if you don't aware of any controller, if you directly write the any code, if you flash it on controller, means it's something you can serve it, but you don't aware what is the root, what is where it is storing, what is memory and all, right? For that purpose I'm explaining. So yes, Sumit.
Okay, so during this course, any specific domain you will be targeting?
Only AUTOSAR I'm targeting.
Okay, okay, yeah.
Only AUTOSAR. This is for just basic. Means if you don't aware of what is controller, means if suppose there will be, we will use in MCAL layer STM32 microcontroller. So if suddenly I will tell STM32 so and so microcontroller we using, means, so if somebody comes what is microcontroller, if that ask at that moment, means it's difficult, right?
Yes, sir.
Yeah, if somebody I will tell, okay, take the sensor data, input data, ADC data, you can convert it in the microcontroller ADC, you do it. Me, if I tell, if we are doing like this means, if I tell, and then suddenly somebody raise question, what is ADC, what is the sensor?
Yes.
Yeah, I was giving not full and final, just glance. At least board should be aware, right?
Yes.
That is the reason.
Okay.
So coming to back, so what and all the inputs we have? We have temperature sensors. Okay, temperature sensor means whether the outside temperature inside the car temperature will differ, right? So that we will take the sensor data and pressure data, any force, any throttle data, if you want to measure, if you want to utilize in the screen, right? That pressure sensors we will use as input, and touch sensors. So whatever the displays we have in cars, right? Inside the car there will be a dashboard. So sorry, not dashboard, there will be a monitor. That monitor also will comes into picture, touch screen, right? For that also we have sensor, we are giving the input. Okay, that pressure sensor, we are ignition, we are push pull. Nowadays we have every car, we don't have any keys, just we will push and open it. So that push pull button also sensors. And coming to the cameras and images. So when it comes to the car, right, we will see the, when you back gear we will do, right, that time also there will be a backside cameras. So that is also we will take from the camera capture and we will display it on the displays. That is also input. And microphones, every day in or day out we are speaking in mobile, right? So that is we will take it as input. And coming to outputs, LEDs, LCDs, like TVs and all we have, right? DC motors, speakers, these are the output sensors, like we can call it as actuators. So printers, these are the major things we will, day in day out we will use. But what is input, what is and output, we will not ever, we will like just like that we will go. So that I just want to give which device is input device, which device is output device. Yes. So in embedded, there will be a multiple firmware we will develop. Like what are the firmware? What is firmware? So the software written for the devices is called firmware because it is permanently flashed inside the chip. Okay, that is the, we will call firmware developer. Okay, there are two main ways to write it in bare metal, where your code runs directly on the hardware with absolute no operating system. Means there will be a no OS like Linux, RTOS, FreeRTOS. This will be the operating system. They won't be there in the bare metal. When it comes to the OS based, right, where your code cite the specific micro operation systems within the software architecture we have, right, that we will comes into picture. Then device drivers, so that CPU how to talk the actional component, right? For that purpose we will write the device drivers code and bootloader. So when you start on any product, any car, anything, before going to the main operating system there will be a bootloader. So bootloader is nothing but what are the start chip, so what are the peripherals need to be enabled, what are the interrupts need to be raised, and boot process. That before the main program it will run the boot program. Then after that boot program there will be interrupts, which interrupt need to be served. And this, I think everyone is aware of interrupts, right? So or else I need to give small glance of interrupt. Can you please confirm on it? Okay, fine. I will give you just one line of explanation about interrupt. So suppose we are doing something, we are in the presentation mode. If somebody raise any question, so that will comes in the interrupt. So we will stop whatever the task we are doing. That we will keep it on side, and whoever is asked the question, that question we will answer. So that is the interrupt. So person who raised the question, right, that we will call is the interrupt. Okay. I think I have given answer. So then coming to the main thing, whatever the test we are writing, everything will come, we need to test it. So that will be stored in the flash and all. Okay, right? So coming to the AUTOS, I think anyone aware of AUTOS?
No, sir. At least from my side.
Yeah, okay, great. Please, Sumit, Amir. Okay, okay. So AUTOS is one of the system operating system. So we have various systems like Linux system, Windows system, and real time operating system. So if you want to anything in specific manner, in specific time, if you want to do it some particular task, for that purpose we will go for the RTAS. Is nothing but whenever the system handles the complex simultaneous actions, we use the RTAS, nothing but real time operating system. Unlike like any standard computer OS will be there, right? Not like that. So particularly specifically, if you see any missiles, right, it should be targeted any particular within the fraction of second, that much mission critical. If you go for the any airbags opening, it should not open any delay after 5 minutes, 7 minutes. It should be open within fraction of second. So for that purpose we will go for the real time operating system. So it will be very precious, it will be very particular time only it will trigger the events. Okay, so that is the thing, we will go it for the artas. Okay, right? I feel I have given a little bit information about the artas. So majorly we have various artas: free artas, safety artas, pxfx, and qnx. These are the various artas we have industrial we are using. Okay, guys.
Okay, sir.
Yeah, please. Thank you for confirmation. Yeah. Then coming to the programming language. So what and all we will use in programming language? You see, mainly we will use the in AUTOSAR C. If adapt to AUTOSAR, mostly we'll focus on the C++. Assembling language is used for whatever the low level drivers we need to do it. That time we will use the assembling language. And Python or micro Python we will using for the scripting languages. Like if you want to test write any script for test automation, then we will go for the Python. And Java we you write, it's like a user interface purpose, we will you go for the Java. When it comes to the Rust language, right? So when it comes to the safety and faster actions is required, then Rust language will comes into which. This Rust is recent days only it is populating, but before and all nowadays is booming is C++, C language. I think everyone is aware of C and C++, at least any one of them, guys.
Yes, sir. Yes, yes.
C or C++.
Both I can say.
Yeah, that's great. Others? Why? Because while running the any controller, right, you should be aware of syntax, you should be aware of requirements. So how the requirement is converted to code wise, you should know the C language at least. Otherwise if you put in C++ also, that is also fine. I feel everyone is aware of C or C++ at least. Coming to environment and tools. So after writing the code we need to compile it. So for that, we if you go for the arm control, right, there will be keel software will be there. That keel software you use to compile the code, and some other softwares are eclipse also is there, vs studio is also there. That is the IDE, we can compile it and we can write the code and we can debug it, that we will call it as IDE. So when it comes to the compiler, right, just we will compile it any right sort of code. So then we will flash it. That is the compiler. Then debugging. So if you have any bugs, right, so that bugs need to be debugged. So we can keep it the point to point breakpoint. Then after that breakpoint, you need to be check whether the register is enabled, register is not enabled. For that purpose, we will do the debugging. and emulators. So if you want to test your code without any hardware, so simulating that we will use the emulator or simulators. Coming to JTAGs. So after writing the code, there will be a exe file will be generated that you should be dumped into the hardware. Then only our whatever the controllers will write the code, right? That only will work. That purpose we will use JTAGs. Okay, logic analyzers. Nothing but if you want to probe the signal, if you want to check whatever the data, so you can capture through in the logic analyzers. Okay, so if you want to next is flasher. So after completing the flash, right, so if you want to upgrade the firmware, so then we will go for the flasher tools. These are the st links and j links which comes into picture. So these are the tools environment we will going to use in AUTOSAR. So some of the companies will use Keel, some companies will use VS Studio, some companies will use Eclipse IDEs. This depends upon their licenses, depends upon the requirement and all. Okay, right? Got it regarding some idea.
Yes, sir.
Yes, sir.
So coming to the protocols. So major protocols. These are the heart of the any embedded system. So when it comes to the data, if you want to take it from the ECU, electronic control unit, to outside port, so there will be a multiple ways to the take the data from actional hold to inside the ECU. So for that there will be a multiple protocols is there. So when it comes to the protocol, UART is the first protocol, very basic protocol. So UART is nothing but universal asynchronous receiving and transmitting. So it is majorly used for any GPS modules, take the data or Bluetooth devices and all. So it having the two lines, transmitter and receiver. So I was giving just what is what. So majorly this is the about UART. When it comes to the SPA, this is the four-way communication we will use. So there will be a master out, slave in, master out, clock, and data pin will be there. So there will be four lines. So this is majorly used for any flash. This is having the highest speed, 100 megahertz till 100 megahertz kbps. The data can be transmitted and received. Yes, right. So that is the main thing we'll do in the SPA. When it comes to I2C, so I2C having the two lines. So one is data, one is clock. So here what happens is whenever any sensor data like any temperature or a throttle, any speed, if you want to go for it, then you will go for the I2C. So majorly we will use for the flash communication. If you want to transmit and receive data, then I2C communication we will use. Then majorly after that comes into picture CAN bus. CAN bus is widely, every automotive industry use the CAN bus. So these are the bus you can use for the cars, trucks, any industrial machines, any not only industries, even the aerospace, even the fighter jets, anywhere CAN communication will be very must. So they will go for majorly into the CAN bus. Okay. Then after coming to the USB, so everyone day in day out you will use USB keyboard, USB mouse, something they will call, right. That protocol is also used by the embedded systems. So this will be one of the protocol we will use in the embedded system. Then coming to the wired and wireless communication purpose. So in networking system, we will use the communications like Ethernet or else Wi-Fi. So both are the Ethernet is like wired communication purpose and Wi-Fi is the wireless communication. So when it comes to the IoT, right? So smartphones having the Wi-Fi systems. When it comes to the any systems and all, so we will go for the Ethernet communication, right? These are the major protocols. There will be another protocols also, analog to digital converter and PWM, watchdog timer. There will be multiple things is there. So this is the glance I was giving what under the protocols is there. So that if you configure in any AUTOSAR PSW module or else in the MCAL module or else in application layer, so you should be aware of it. So where the data is coming, on what protocol is coming, how the processing is happening. So I was giving this Small input. Next, so power management. So I feel communication protocols is fine, right? So apart from this, if anyone wants to know any other protocol, please let me know. Now I can explain. Okay. I feel. Okay. Coming to the power management. So power management in embedded system very essential. Without the power, whatever the protocol, whatever the application you write, so waste only. So first coming to the why power matter. So if you don't have any power, right, you not able to turn on any system, even the car, even the batteries, even the whatever the printer, micro, whatever the things inside the washing machine, anything, nothing will work. So power is the main thing. So here the power, right, there will be a modes, multiple modes. Sleep mode. So when you are not doing anything, right, that time all the controllers, all the peripherals will be powered off, so that won't be run. So whenever it's required, that peripheral will be enabled, then it will be work. So that way it will work the power mode. So coming to the voltage scalability, wake up interruption, these are the power battery management systems. So nowadays everyone is going for the EVs. So in EVs, right? So there will be a one system, whole bunch of system, battery management system. So how much power should be utilized for the car windows? How much power should be utilized for the airbags ECU, how much power will be utilized for the braking system. These all the power will be calculated in the battery management system. This will be there will be one chapter battery management system. So how much power need to be driven by the controller, how much is required. So that is the main stuff is available in battery management system. Okay, this is a power thing. Power management comes into picture. So in apart from this, anybody having any doubt in power management? Okay. So in embedded system, right, we have multiple applications like smartphones, tablets, and TVs, voice, smart applications, home applications. Not only this, we will use the various domains also, like in the aerospace, in the railways, in the DRDOs, in various domains, in defense also, in automotive also, not only in automotive, in every day in day out, there will be multiple applications we have. Okay, so coming to the major application, everyone is looking for AUTOSAR, right? So here ECUs will comes into picture. So ECU means engine control unit. So it will majorly controls the fuel ejection, ignition, emissions, right? So there particularly there will be a varieties of ECU. One ECU will controls the fuel ejection, one ECU controlled by the ignition, one ECU controlled by the emission. These various ECUs will be there. Then after that comes into picture ABS, anti-lock braking system. So while slipping any brakes, right? Bikes nowadays ABS is incorporated in bikes, at the same time in cars also. So it is a everyone is looking for ABS. So in a fraction of second, how the things is working, like brake should be calculated, how much pressure need to be applied to the any brake, right? That will comes into picture in ABS. If you put more pressure on the brake, right, you will be slipped or the vehicle will be rotated. That will takes into picture in the ABS systems. Okay, then airbags. Airbags will be opened within the 15 milliseconds. If it is not opened within 15 milliseconds, major damage will happen to the humans. So that is the thing. There will be a separate system will be developed in any industry, any company in any car, BMW, Bosch, anyone looking for this airbag. This is a major critical part. Okay. Then coming to the navigations. So where we are, where if we want to go. So that will comes into picture the navigation purpose. So okay. Then coming to the controllers. So if you want to control all these things, automate the things, so there will be a PLCs, so programmable logic controllers. So if you want to do any particular purpose, everything will be done by programming, so that will be controlled by PLMs. Then after that, robotics, any industrial robotics and all is there also we will use the embedded system. Then CNC machines, so we will cut the any hardware, any machinery, right? There also we will go for the CNC machines. Okay, these are the various applications in automotive and industrial systems for embedded. Till now, anyone having any doubt?
No, sir.
Yeah. Then in medical also, with in medical also we will use the various microcontrollers and the MRIs and smart agriculture and fitness also we will use the embedded system. IoT is nothing but our day in day out using the mobile phones, right? That is also comes under the embedded system only. These are the various applications of embedded system. So if you fail in real time, right, we have various challenges like the real constraints will be there, power limitations will be there, security vulnerabilities is there. These things comes into picture. These are the challenges. Yeah, that's it about I feel embedded system. I feel I want to give just overview. That's it, not most deeply into the embedded system. So if we want to try, right, try to explain embedded means you need to take the controllers, peripherals, power management, what is interrupt and all comes into picture. I feel somehow I have given some knowledge regarding the embedded, what is what. Till now, anyone having any doubt?
No, sir. Got it.
Yeah. So next class onwards, I will go for the main topics of like AUTOSAR. Okay.
Okay.
Yeah.
Okay, sir.
Hussein, any doubt?
No doubt, sir. It's
Yeah.
clear.